So far, when you've been doing things with quadratics, you've always been dealing with them as real quadratics with real solutions. So, what I mean by that is, these coefficients a, b and c are all real numbers, and the solutions you're looking for are also real numbers. So, you've had a table like this before, where you've gone, this discriminant, remember that's the bit under the square root in the quadratic formula. If that discriminant, b squared minus 4ac, is greater than 0, if it's positive, then you're looking for two solutions. If it's equal to 0, then there's one solution because you're plus or minus 0, so there's only going to be one solution. And if it's less than 0, well, you can't get the square root of a negative number, so there's no solutions. But wait a minute. Now, with complex numbers, you can get the square root of a negative number. So we're now going to talk about complex factors of quadratic expressions, complex solutions to quadratic equations. Now, make sure you understand the difference. This is a quadratic expression. Okay, the bit without the equals, this is a quadratic expression. I can factorise this and find linear factors, but I can't solve it. If I want to solve it, I must have this expression equals something. And the normal method, however you're doing it, real or complex, the normal method to solve a quadratic is to make it equal to 0. Rearrange it if you have to, so that it says it's equal to 0. Okay, we're still for the moment looking at real quadratics, where a, b and c are real numbers. If they're real numbers, and the discriminant is greater than 0, then you are going to have two real solutions to the equation. If the discriminant is equal to 0, you are going to have one real solution. Actually, you've got two complex solutions, but they have zero complex part, zero imaginary part, which means if they're conjugates of each other, then they must actually be real numbers. So they turn out to be the same real number. If the discriminant is less than 0, you've got no real solutions, but you actually have two complex solutions. And they are actually conjugates. Conjugates, I can't spell it. Two complex conjugate solutions. Okay? You'll see that when we do some examples later. You'll see how these always turn out to be conjugates. Now, I want to split up this top row a bit more because I want to fill in the technique column. How should you go about trying to factorise and solve? Well, if there's two real solutions, there's two options. Let me do it this way. If it's greater than 0 and it's a perfect square, then you should just factorise as you are used to doing. That means look for two numbers that multiply to AC and add to B. Split up the B term into two parts and factorise. If you need practice at that, I'll try and provide some links for you. If it's greater than 0 and it's not a perfect square, then you're going to sit there a very long time trying to directly factorise it by splitting up the middle term. However, you can solve it quite easily by completing the square. If you've forgotten how to complete the square, again, I'll provide some links for you for how to go about doing that. If the discriminant is 0, there is going to be only one real solution. It should be pretty easy to do, but what you've actually got is a perfect square. So I'm still going to say completing the square is the technique to use. Because this part is 0, so you're just going to end up with negative b on 2a as your two solutions if you're solving. If you're factorising, it should be pretty easy to work out what to do, because it should match this formula. A plus b squared equals a squared plus 2ab plus b squared. Or you might have oops, it's not quite going to fit. A minus b all squared, which is a squared minus 2ab plus b squared. It's always plus the b squared. Now that's important when you come to actually doing the factorising. It's always plus b squared. This first sign goes with the sign in the brackets. So what I'm saying is when the discriminant is equal to 0, usually you'll be able to straight away recognise this or this and factorise it directly. Okay, what about if the discriminant is less than 0? Well, we're going to be looking for complex conjugate solutions, and the same technique applies. You're going to complete the square. Now, if you are solving the equation, there is an alternative for this one and this one. And that alternative, if you're solving, is to use the quadratic formula. That is the final option for either of these two. When it's not 0, basically you can always use the quadratic formula if you are solving. But if you are just factorising an expression, quadratic formula won't help you. You actually need the factors, so just complete the square instead.